Hello and welcome. Today we're going to learn about the distance and midpoint formulas. First, we will tackle the midpoint formula. You should remember from the last topic what a midpoint is, but we never learned how to find them given the locations of the endpoints of a segment, and that is precisely what the midpoint formula does. But let's derive it before jumping into using it. Here we have a generic line segment. To find its midpoint, let's look at each axis separately, starting with the x-axis. Knowing that midpoints are perfectly in the center of the segment, they will also be in the center regarding just the x-axis. So if we could find the middle of the two x values, we could find the x value of the midpoint. And what method do we know for finding the middle of two values? Well, averages, specifically the mean, where you add two values and divide by 2. So in this case, x sub 1 plus x sub 2 all over 2 will yield the x value of the midpoint, and we can do the same thing for the y value. So with that, here's the formula. While you should memorize this, I like to think of it as simply taking the averages of the x and y values of the 2 points. Now that we have derived it, we can apply this formula to some practice problems. Starting with the x values, we can add 1 and 6 to get 7, and then divide it by 2 for 7/2 as our x value. We could simplify this, but it isn't necessary as fractions are fine either way. Moving on to the y values, we add 2 and 8, yielding 10, and divide by 2 to get 5. So, putting them together, our answer will be 7/2, 5. And always remember the parentheses. Unfortunately, you will not always get a diagram to make it clearer, so we must also practice some problems in word form. Here we are directly given the coordinates of the 2 points, so we should use the midpoint formula. But first we must label our 4 inputs. Now we are ready to use it, so let's pull it up, or write it if your problem is on paper. And then we plug in each of the inputs. And now we simplify, first by adding, getting 16 on the left and 3 for the right. And lastly, we divide each by 2 to get 8 and 3/2 as our coordinates. With this, however, we can find more than just midpoints. We can find any of the 3 points given the other 2, including endpoints, which we will learn next. Given the coordinates of points A and M, and the fact that point M is the midpoint of line segment AB, we can find the coordinates of point B. But how? Well, we know that the change in each direction between points A and points M and B are the same because, well, M is the midpoint, and we can find that change by subtracting the x or y value of point A from that same value of point M. And once we know the change, we can apply that same change to point M to get to point B. Now let's try this on a problem. To start, we find the change in the x direction by subtracting x sub 1 from x sub 2, which in this case means subtracting 2 from 5 to get 3, which we then add to 5 to get 8 as the x-coordinate. Next, we subtract 1 from 3 to get 2, and add 2 to 3 to get 5 as the y-coordinate. And putting them together, point B will be at the coordinates 8, 5. Like finding midpoints, we will usually not be given this diagram though, so now we should try it on a problem without. We have been given the coordinates of one point and the midpoint, so let's start by finding the difference in the x direction by subtracting the x-coordinate of the endpoint, being -2, from the x-coordinate of the midpoint, being -4, which gets us -2. Next, to find the difference in the y direction, we subtract -4 from -6 to get -2 once again. And now we add the differences to the midpoint coordinates to find the endpoint. So -4 plus -2 and -6 plus -2, which yields -6, -8 as our answer. And as always, don't forget the parentheses. We have learned all about finding different points on line segments, but never how to simply find one's length, which is what we should do now. Using the distance formula, which can find the distance between any 2 points, even without there being a line segment there. Like the midpoint formula, instead of getting straight into using it, let's derive it. Before we do that, however, we must first review the basics of the Pythagorean theorem, because it has been a whole course since we used it. So, the Pythagorean theorem relates the lengths of sides of a right triangle using the formula on screen, where C is the hypotenuse or longest side, and A and B are the other two. Specifically, we want to isolate c, the hypotenuse, in this formula, which we can do by taking the square root of both sides. You may notice that there should be a plus or minus symbol next to the square root, but because a line segment can't have negative length, only position, the minus is ignored. You're probably wondering how this is remotely helpful to the distance formula, which we will find out now. Returning to the problem, given these coordinates, how can we find the length of this line? Well, we can look at it like a right triangle, which is hopefully more apparent with these red lines. But how is this helpful? Well, we actually know how to find the lengths of the two shorter sides here. The horizontal one is just the difference in x coordinates, and the vertical one is just the difference in y coordinates. Now we can use the Pythagorean theorem to find the length of the hypotenuse. So let's plug our lengths in. And we can isolate c like before by square rooting both sides. And that's it. Right there is the distance formula, specifically the right side. Usually you don't write as c. Just a fair warning, you will definitely need to memorize this. But the way I'm about to do is identical to just plugging things in, so you can do either way. And speaking of, let's get into trying it out. For this problem, we have been given 2 points and tasked with finding the length of the segment that connects them. So, to start, we find the difference in x-coordinates, which will be 7 minus -1, or 8, and then find the difference in y-coordinates, being 3 minus -4, or 7. Now we plug in 8 and 7, and square them separately to get 64 and 49, which, when added together, becomes 113. Typically, this is good enough for your answer. However, some teachers will make you approximate the root, so I would ask them before your next test. However, either way, you need to remove the root if the number is a perfect square. Please don't write square root of 9 as your answer. Moving on to our last problem, same deal here. 3 minus -3 is 6, and -5 minus 0 is still -5. You might see the delta symbol, it just means difference, so the difference in x is 6 here. And now we plug in the differences. Once again, 6 squared is 36, plus 25, which is -5 squared, which together get you 61, and 61 is not a perfect square, so root 61 is our final answer. Hopefully all that was clear, but as always, feel to rewatch if you didn't get it all. But for now, let's do some comprehension questions. Pause to try them out. And here are the answers. Thanks for watching. I hope you enjoyed and learned something. See you soon.